Today we're going to be looking at how to read and how to evaluate with radical signs with square root signs. So first, let me ask you, what is the opposite of addition? What operation is the opposite of addition? Of course, it is subtraction. What is the opposite operation of multiplication? Of course, it is division. So the question would be, what is the opposite of squaring? For example, if you have 4 squared, which is 16, what would be the opposite operation of that? Well, we know that the opposite of squaring is square rooting. And we use something called the radical sign to represent this. Some people call this the square root sign. It's actually called a radical sign. And when there is no number right here, it's an understood 2, which means the square root of a number. You'll also find as you progress in your math that that can also be the cubed root of something or the 4th root of a number. So what is outside can change, but if there's no number there, it's an understood 2, which means it's the square root of that number. So we can just see that these are opposites. The square root of 16 is asking what number multiplies times itself to get 16. And that, of course, would be 4. There's that understood 2. So even though there's no 2 written right here, when there's no number written there, it's an understood 2, which means the square root of a number. What number multiplies times itself? So these are opposites, squaring and square rooting. We have to be really careful about the negative signs. If there is a negative outside of the radical sign, then we read this the opposite of the square root of 16. So to evaluate that, we would take the square root of 16, which is 4, and the opposite of that would be a negative 4. If you happen to be taking notes, if you copied off the notes and are taking them, we're going to practice reading them, because if you can read them correctly, you can evaluate them correctly. So our first one, right here, you have a radical sign with a 49 underneath it. We read that as the square root of 49. To evaluate that, we ask ourselves, what number multiplies times itself to get 49? And of course, that is 7. The next one, because there's a negative sign outside of the radical sign, we would read this as the opposite of the square root of 36. So to evaluate it, we ask what number multiplies times itself to get 36, which of course is 6. But we want the opposite of that number, so that would be a negative 6 when evaluating it. In our next example, notice this time that the negative is underneath the radical sign. So where this says is the square root of negative 64. So if you ask yourself, what number multiplies times itself to get a negative 64? Well, if I go 8 times 8, that's 8 multiplied times itself, that's a positive 64. What if I do a negative 8 times a negative 8? Well, that also is a positive 64. There is no way to multiply a number times itself and get a negative number, because if the number is positive, the answer is going to be positive, and if the number is negative, when multiplying 2 negatives, you also get a positive. So this one you cannot actually evaluate. This one, the negative is outside the radical sign, so it reads the opposite of the square root of 25. So we ask ourselves, what number multiplies times itself to get 25, which is 5, and we want the opposite of that, so that would be negative 5. In the next example, what is the square root of 144? And that is just simply 12, because 12 times 12 equals 144. Now, sometimes we have numbers under the radical sign that are not perfect squares. So first, let's stop and think about what the perfect squares are. Perfect squares where you take a number and multiply it times itself. So 1 times 1 is 1, so the square root of 1 is 1. 2 times 2 is 4, so the square root of 4 is 2. 3 times 3 is 9. So what we're doing here is we're listing the perfect squares. Square root of 1, square root of 4, square root of 9 is 3. What do you think the next square root would be? 4 times 4. Square root of 16, which is 4. 5 times 5. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And the square root of 144 is 12. Now these are numbers that you need to be familiar with. You need to know what the perfect squares are. So you should be able to recognize the square root of 1, the square root of 4, the square root of 9, all of these being perfect squares. Now, sometimes we have a number under the radical sign that is not a perfect square. For example, the square root of 28. So what we're going to do is we're going to think about the perfect squares that are right below it and right above it. In the list that we just wrote, we had right below it the square root of 25, and right above it was the square root of 36. So the square root of 28 would fall between these two numbers. Well, we know that the square root of 25 is 5 and that the square root of 36 is 6. So we know the square root of 28 is going to be a decimal somewhere between 5 and 6. So if we were going to estimate that, let's look up here. We have the square root of 25, the square root of 36. Now the square root of 28, is it closer to 25 on a number line? Is it closer to 36 on a number line? Where would it be? It's only 3 away from the square of 28 or 25, but it's 8 away from this one. So we know it's going to be closer to 5. So the decimal would probably be somewhere about 5 3/10. If you want to check that, you can plug it into your calculator and say the square root of 28. And you will find that if you round it, it is 5 3/10. So we're just trying to estimate and get close here. Okay, let's practice that again. Square root of 90 is not a perfect square. If you look at those lists of the perfect squares, right below it we have the square root of 81, and right above it we have the square root of 100. Well, we know that the square root of 81 is 9. The square root of 100 is 10, so we know that the square root of 90 is going to be somewhere between 9 and 10, so it's going to be 9 and some decimal. Well, 90 is about halfway between 81 and 100. So I'm going to guess it's probably about 9 5/10, and when you do it with your calculator, you will find that that is correct. This is something you need to work on mentally. You may not get the exact decimal when you're estimating and guessing, but see if you can get close, and then you can check with your calculator. Now let's practice evaluating with some radical signs. If you have the square root of 64 times the square root of 64, and we were going to evaluate that, we would take the square root of each number, which is 8. So we have 8 times 8, which is the same thing as 8 squared, or the answer would be 64. So I want you to look for a pattern here. When we multiply two radicals and the radicand, the number under the radical sign, was the same, when you evaluate it, you actually get that number without the radical sign. Let's see what happens here. The square root of 49 times the square root of 49. Well, that would be, if I evaluate that, would be 7 times 7, or 7 squared, which is 49. So again, when you have two radicals multiplying times each other and they're the same, then the answer, these square roots just basically cancel each other out, and you're left with the radicand with a number that's underneath it. So that was easy when you had perfect squares. But what happens if we have a radical that's not a perfect square? Well, we could take our calculators and we could figure out the square root of 53, and then we could multiply it times itself. But if you know this rule, and you know that when you have the square root of a number times itself, that the square root signs just cancel each other out, the answer is just going to be 53, because it works just like it did in the above examples. So if you have a square root multiplied by itself, that number is squared. The two are opposites, so they cancel each other out. That just means that when you have two square roots the same multiplied times each other, these radical signs just get canceled out, and you're just left with the number underneath, which is called the radicand, as the answer when you evaluate it. That makes mental math a lot easier. Okay, if you were to look at this one, this reads the square root of 40 plus 9. Now, we have to follow our PEMDAS, our order of operations. So the first thing we need to do is evaluate what's underneath the radical sign first. So we would have to do the 40 plus 9 first, which of course is 49. So now it reads the square root of 49, which of course is 7. For another example, here we have underneath the radical sign 77 plus 4. We want to evaluate that first. And 77 plus 4 is 81. So what is the square root of 81? 9. This one is a little longer, but don't let it scare you. Notice that there is no operational sign between the 4 and the radical. Remember, we've talked about this, and when there's no operational sign in algebra, it's an understood multiplication. So what this actually reads is 4 times the square root of 121 plus 3 times the square root of 81. We would want to follow our order of operations. So first we have to evaluate what's underneath the radical sign first. So when we do that, the square root of 121 is 11. So that would be 4 times 11. And the square root of 81 is 9. So we would have 3 times 9. So we evaluated what was under the radical sign first. Now we have to do our multiplication before we can do our addition. So that would be 44 plus 27, which then you can add and get 71. So it's just a matter of following the correct order when you fill these out. This one would read 5 times the square root of 64 plus 2 times the square root of 16. We know that the square root of 64 is 8, so that would give us 5 times 8. We know that the square root of 16 is 4, so that gives us 2 times 4. Wrote that right on top of that. So we have 5 times 8 plus 2 times 4. We do our multiplication first, so that would be 40 plus 8, and we know that 40 plus 8 is 48. When you have a fraction underneath a radical sign, what we are going to do is take the square root of each number. So the numerator, the top number, think about what is the square root of that number, and then what is the square root of the denominator, the bottom number. And when you take the square root of both of them, you simply get the square root of 25 is 5, and the square root of 49 is 7. So it would just be 5/7. You keep the square root of 25 on top, which is 5. You keep the square root of 49 on the bottom, 7, reads as 5/7. Let's look at an example here. Nancy wants to plant a square garden of wildflowers. Square means we're going to be using squares and square roots. Usually when we have a square to indicate it's a square, we have a slash on each one to show that they're all the same length. She has enough wildflowers to cover 19 square feet. Estimate to the nearest tenth the side length of a square with the area of 19 square feet. So basically, we want to know what is the square root of 19. Now, this is not a perfect square, and notice it says to estimate. So we're going back to our estimation skills. We think about the square roots that are right below and right above square root of 19. I know below it I have the square root of 16, and above it I have the square root of 25. These are the perfect squares. The square root of 16 is 4. The square root of 25 is 5. So I know it's going to be somewhere between 4 and 5. It's going to be 4 and some decimal. 19 is a little bit closer to 16 than it is to 25. So I might estimate somewhere around 4 and 4/10. Just try to get close. If you miss it by a tenth, you could check with your calculator after you practiced estimating, but that just gets you close. And this symbol right here means approximately. That means it's been rounded. It's getting close. On the assignment that we're going to practice on today, pull it up here. We're just going to do a few. Let's look at the first section here. If you're given a square and you're given the area, and this is a square, it doesn't look like a square, but it says that it's a square. So we're going to assume that all the lengths are the same size. We know that the area of a square is the base squared. So all you have to do is take the square root of this number to find the length of each side. So all it is asking is what is the square root of 100, which of course is 10. So each side is 10. And that would work because when figuring out the area, you always do base times height, and 10 times 10 is 100. Again, this may not look like a square, but it tells us it's a square, so we're going to assume it is. So to find the length of each side, all you have to do is take the square root of the 49, which of course is 7. So each side of the square is 7. I'm just going to kind of look down here and do an example or two. Let's look at W. This one reads 3 times the square root of 121. I like how my eraser's working there today. So that would give us 3 times what is the square root of 121? It is 11. So then we ask ourselves, what's 3 times 11? So the answer would be 33. If we look over here at the next part, this time, instead of given the area, you're given one of the sides. And they tell you that it's a square. So to find the area, all you have to do is the side squared. So 8 squared would be 64. When looking down here, look at the difference between H and W. H reads the square root of 100 minus the square root of 64. So I have to evaluate each radical first. So the square root of 100 is 10, and the square root of 64 is 8. So it's 10 minus 8, which is 2. That evaluates differently than the next one. This one, it's all under one radical sign, so we have to evaluate this part first. And 100 minus 64 is 36, and the square root of 36 would be 6. So they do not evaluate the same. If we were to scroll down here, these get a little more difficult to think about what we practiced, especially this one right here. 38 is not a perfect square. So you could take your calculator, and if you type in the square root of 38, you're going to get this decimal, and you're going to be multiplying times decimal. But remember the rule. When you have a radical times itself, the square roots cancel each other out. So the square root of 38 times the square root of 38, without me having to type anything into the calculator, I know it is 38. Trying to think of which one I think you would have the most trouble with. Let's just try the first one. So first we have to find the square. So under the radical sign, we have 12 squared, which is 144, plus 5 squared, which is 25. And underneath, we add those together, so we would have the square root of 169, and the square root of 169 is 13. So you just need to follow your order of operations. Here's an example of the fractions. This one says the opposite of the square root of 1/100. So you're going to take the square root of 1 on top and take the square root of 100 on the bottom, and then take the opposite. So it's going to be negative. The square root of 1 is 1. Square root of 100 is 10. So it's simply a negative 1/10. On this last part over here, this is where we're estimating. Now the answers are at the bottom, so you really should not need your calculator for this. So think about what the two perfect squares would be, one below it and one above it, and then look down there for the answer. For example, on 10, the perfect square right below it would be the square root of 9. That's 3 times 3. So the square root above it would be 16. So we know that the answer is going to be somewhere between 3 and 4. So it's going to be 3 and some decimal. Well, 10 is really close to 9. So it's probably going to be, look down here at the bottom, right here, 3 and 2/10. So all you have to do is figure out what two numbers it's between and look below and use the help that you're given down here. Let's look at another one. Let's look at the opposite of the square root of 30. The square root right below it would be the square root of 25. And above it, we would have the square root of 36. So we know it's going to be between 5 and 6. So it's going to be 5, but the opposite of that, and some decimal. Well, 30 is about halfway between 25 and 36. So if I look down here, oh, looky there, a negative 5 and 5/10. I didn't even need my calculator for that. So hopefully, as you work through this paper, you will begin to see how to evaluate square roots and have some success with that.